Okay, 7th grade, we got example 2 here on percent of change. 3 more problems. They're pretty much set up the same way as the first example. So if we look at these 3, our first one is 33 to 80. So we're starting with 33 of something. We end up with 80 of it. And we're asked to find the percent of change. So again, like the last one, this is amount of change over original amount. Amount of change is just subtracting the 2 numbers. So we're doing 80 minus 33. Again, a bigger number minus smaller number. The original amount, which is what's on the bottom of the fraction, that's whatever we started with. We started with 33 in this case. 80 minus 33 is 47. So I end up with 47 divided by 33. Get my calculator here. I'm just going to do that division. 47 divided by 33, and I end up with 1.4242. So then I move my decimal 2 to the right, just like we've been doing, and I end up with 142.4 when I round to the nearest 10%, and we went up, so it was an increase. And you can see we ended up with over 100%. That can happen. You can end up with a over 100% increase. But can you end up with more than 100% decrease? Think about that question. I'm just going to sit here and wait. I want to walk away. You think. I'm back. You cannot have more than 100% in decrease. Think about it. 100% decrease would mean you'd lose all of it. If I had $50 and I was telling you, you're not 100% decreasing the amount of money you have, now I've got $0. That's all 50 would go. You can't do more than a 100% decrease. So let's talk about the next one. 14 to 28. Hopefully you look at those numbers and you recognize, hey, that one's double that one. What do you think that means? What kind of increase do you think this will be if we're doubling a number? Well, let's calculate it and find out. We subtract the 2 numbers, 28 minus 14. Our original amount is 14. We do the math here. 28 minus 14 is 14. Still over 14. 14 divided by 14, I don't need a calculator for that. It's 1. Is our answer a 1% increase? No, because we still got to move our decimal 2 places to the right, just like we did in this problem, just like we did in example 1. There's no decimal right now, but I know it's here. So if I move it 2 to the right, this is going to end up being 100, because I got to fill in 2 zeros there. This is a 100% since we went up. It's an increase. So going from 14 to 28, doubling a number is a 100% increase. So what do we look at the next one? It's kind of the opposite here. It's 28 to 14. Do we think this is going to be a 100% decrease? Logic would say if this is a 100% increase, that would be a 100% decrease. But it's not actually the case. So because we starting at 28, if we were going to do a 100% decrease, we'd end up with 0. We would lose everything, but that's not what's happening. We're actually only going down by half, right? 28 to 14. 14's half of 28. So what kind of decrease do you think this is going to be? Well, we'll calculate it. So again, we're doing 28 minus 14. We subtract our 2 numbers. The top is always just the amount of change. Subtract the 2 numbers. The bottom, though, is the original amount. It's what we started with. Unlike this problem where we start with 14, this one we're starting with 28. So we do the subtraction, we get 14. So we have 14 over 28. I do that division, I get 0.5. 0.5, I got to move my decimal 2 places to the right. 1, 2. I would fill in a 0 there, and I'd end up with 50%. This is a decrease. So if you ever have half of something, you start with a number, you end up with half of it, that's going to be a 50% decrease. All right, that's example 2. Come back for one more example of the word problem.